here. Minusing that like we do. Watch out for those sign changes. 6 minus 6 is gone, as it should be. This is 21, and it looks like plus 15, but we're minusing it, so it's always opposite of what it looks like. So that's a minus 15. 21 take away 15 is really a 6, x to the 3. And then this looks like minus, but it's a minus minus. So that's a plus 3. So 8 plus 3 is 11, x squared. Positive. Dropping the next one down, that'll be a minus 13x, and we'll try again. Couple of rounds of this and we'll be good. 2 into 6 is once again 3, so positive 3. X to the 2, one more x I think will make 3 x's. That'll be good. So one more x on top of those 2 will make 3 x's, and that's good. That's 6x squared. And then we'll distribute it. 3 times 2 is 6, x to the third again. 3 times 5 is 15, x to the 2 again. But just x2 this time, and then 3x times minus 1 is minus 3x. Minusing this thing, now we've got 6 take away 6, and then 11 take away 15. That's going to be a negative 6, I guess. Is that right? Negative, is it 4? Negative 4, I think, x squared. And then 13x minus 3x, except it's a negative. Okay, so it's a negative 13. This looks like minus, but really it's a plus. This is minus minus this. Negative 13 and positive 3 is negative 10x. And then from there, we're dropping the last one. We got minus 4 going on. And so then, let's see here. Regular 2x going into negative 4. 2 into negative 4 is minus 2 times. And then, let's see here. I have x squared already. I need x squared. I don't need any more x's, I don't think. Let's see if that works. So let's see. We got negative 2 times 2 is negative 4x squared. Looking good there. Negative 2 times 5x, it's going to be negative 10x. That's good too. And then negative 2 times negative 1 is positive 2. Looking at that, we won't have much remainder. These cancel out because they're both the same. And then we have negative 4, and that looks like a plus 2, a positive 2, but remember, it's minusing. And so we'll have negative 4 take away a regular 2. So negative 4 take away 2, or negative 4 minus 2 is negative 6, and we'll say, oh, you can't see that. It's a negative 6 remainder. And so then we'll just say that. We have ourselves a quotient of 3x squared plus 3x minus 2. That's the quotient part. And then our remainder is just negative 6. And if you want to put that in the fraction form, that's negative 6 remainder out of whatever it was you were dividing by in the first place. That's 2x squared plus 5x minus 1. That's one classic way to write it. However you're using that application, of course, this is the quotient part, and then the negative 6 part is the remainder. Cool. Okay, what else? What number was that? Oh, yeah. That was number 7. No, that was number 8. Okay. Then numbers 9 and 10. We have write a polynomial of least degree with integer coefficients or integral coefficients that has the given zeros. They're giving you zeros, you just got to make the function. And so this goes quick enough to start it off. We just say f of x equals x minus each of these things would be probably the easiest way to go. X minus 4. Done. X minus negative 1 is x plus 1. And then x minus 5. Looking good. And then from there, it becomes a little bit of a game. You got to start foiling junk out. And so let's see, if I started by foiling these out, this is where it becomes a headache, you know. That's x squared, and then minus 5x and plus 1x, and then minus 5, so that's going to be x squared. Minus 5 and plus 1 makes a minus 4x, and then minus 5. And then all of that I'm supposed to FOIL with this x minus 4 now. And so then that's going to be a thing. So let's see here, x times x squared and all this stuff. So x gets a turn. X times each one of these would be x times, okay, so that's x3. And then minus 4x squared. And then minus 5x. And then we have negative 4 times all of those. Now it's the 4's turn. Negative 4 times x squared. Minus 4x squared. Minus 4 times minus 4x would be a positive 16x. And then a minus 4 times minus 5 is plus 20. And then from there, let's see here. We have x to the 3 is sitting there. So we'll keep that. X to the 3. Then our x squareds are minus 4 and minus 4. So that's minus 8x squared. And then let's see here, minus 5x and plus 16x, that's a plus 11x. And then we have a plus 20, it looks like. And then, unless I messed something up, that looks pretty good. So this is just a foiled out version of it. I like this version better, but it's good to be able to manipulate some stuff. Okay, same idea here. Just remember we have -3 multiplicity of 3 just means we have a bunch of the same thing. So that's x minus -3, which is x plus 3, x minus -3, x minus -3. It just means you have that many of that one, that's all. And then you would handle it in the same way. You foil it out like we did on the last one. Okay, find all zeros. This is wonderful when they tell you what just to find the zeros and it's already in factored form. What we got here, guys, is this is x times x minus 1 squared. You know that's x minus 1, 2 of that. And then 2x plus 1. And we just got to figure out how to make each one of these things equal 0. A lot of them you can do by just looking at them. If I wanted to do something minus 1 is 0, that's positive 1. So positive 1 is a 0 there. Same thing here. Positive 1 take away 1 makes 0. 2x plus 1 is not quite as obvious. If you need to, you can always just do it by algebra and say, well, I want this thing to equal 0 and start, like solving it like we do. We'll get rid of the plus 1, and then we have 2x equals 0, take away 1 is -1. Divide the 2. We got x is -1/2. That'll work. So we have a positive 1, a positive 1, a -1/2, and then this one, classic, it's just an x sitting there. So if I put in a 0 for x, then the whole thing will be 0. So 0 is another one of them. It's a little bit weird to circle an answer when your answer is 0, but we'll do it. Anyway, so we have 0 and 1 and 1 and -1/2, looks like. And then, of course, you can say that since these two are the same, that's -1/2 and 0 are normal, and then you would say, and this is positive 1 of multiplicity 2. Multiplicity 2 would be one way to say that. Same challenge here. We're supposed to find the zeros, but then it's not as obvious how to do it because it's not factored. And so it'd be cool if we could just factor this thing. It's in third degree, but it's just they're hard to factor unless you happen to see something just special by grouping or something. And so we might have to do back to, let's see, what goes into 5 over what goes into 1, I guess. Not very many things go in. Positive 1 and positive 5 go into 5. And then we'll do a plus or minus version. And then only things that go into 1 are 1. So it looks like as far as finding rational, nice zeros go, it looks like either be a 1 over 1 or a 5 over 1, or a negative of one of those things. So let's see what we can try with each one of those. Hold on, I gotta pause this and go back to something. So then by synthetic division, it looks like this. You guys don't know how long I paused that for, do you? It's always mysterious to me on this end. I should probably not even mention it when I pause the video. It's a little weird. Okay, got the coefficients down, 1, 7, 5, 11, whatever. And we go, let's see if we can find ourselves a 0, but it's the same thing we've been doing. The only reason I bring this up is I feel like this one we might have to do it in a messier way after the fact. And so let's see how that goes. Okay, drop in the 1. That's a 1. What should we try, a 1 or a -1? Or a 5 or a -5? Let's try a positive 1 here. We'll keep that list separate. So if I do a positive 1 here, that's supposed to look like a 1. 1 times 1 is 1. -7 plus 1 is -6. Timesing that by 1 is that still. This adds up to, what is that? 11 minus 6 is 5. And then 1 times 5 is 5. -5 plus 5 is 0. Perfect. First try. Loving it. Now we just got to say, looks like we found one of the zeros. It's positive 1. So we got one of the zeros is positive 1. And then the leftovers is going to be x squared minus 6x plus 5. I'm trying to think of things that go into 5 that add up to -6. That might actually work. Let's see if we do double negatives. This one factors as well. So just try and find out the factors that make that and then equal them to 0. Looks like you got yourself some zeros. No big deal. I thought we might have to use a quadratic formula on that one. Lucked out, I guess. And so let's see. This is the one we left off on, right? Okay, I think this is the one. And so then number 13, let's see if this goes the same way. Finding zeros, I'm going to try stuff, blah, blah, blah. I'm going to skip this one actually so you guys don't have to listen to this forever. So then same kind of thing on 13, whatever. Okay, For each function, we got to identify the holes, the intercepts, and the horizontal asymptote. Notice that there's no request for a vertical asymptote, although I guess anytime we have something that looks like a vertical asymptote and it cancels out, that's when we run into a hole in the graph. That's where it's like, it's the line and then it's just a one little missing piece or whatever. That's what they mean when they say the hole in the graph, instead of a vertical whatever we called it, asymptote. So that being the case, let's see what we can do about this mess. I recommend getting these things into factored form. So if I try to factor this and x comes out of everything, and then I can probably split that up, because once I take the x out, that'll be x squared plus 1x minus 12. So I'm thinking that'll be x plus 4 and x minus 3, and then times that x that's already there. And then if I have this one, I could take a 4 out of everything, and then that would just be x squared. So that's nice. I don't have to do any intense factoring. Things that go into negative 12 that add up to 8. Oh, no, that's not that then. See, if I divided the 4 out, this would be an x squared plus a 2x minus 3 is what's left over, and that's what I got to factor. So things that go into negative 3 would be like a 3 times 1. Let's see if we did a minus 1 and a plus 3. That would make positive 2. Looking good. And you'll notice here that none of these factors at the bottom cancel with any of the ones at the top, in particular the x part ones. This doesn't really have much to do with it, but that means holes in the graph, they're what happen when you have something that would be making this undefined, like positive 1 makes this undefined, and negative 3 makes this undefined. But then if they cancel out, like if I had an x plus 3 and an x plus 3 or something, they would cancel out, and then that means this has a removable discontinuity, and I'll have a hole in the graph instead of a vertical asymptote. As it is, these things, x minus 1 doesn't cancel. There's no x minus 1 up here, and there's no x plus 3 up here either, so neither one of these makes a hole in the graph, so there are no holes. No holes in the graph. Instead, positive 1 and negative 3 are vertical asymptotes. We also have to know about intercepts. So there's x-intercepts and y-intercepts here. Remember, x-intercept, that's when we're making the top equal to 0, because if the top is equal to 0, then the whole function is equal to 0. And so let's see here. For an x-intercept, let's see here, I would do a negative 4 plus 4 would make a 0, so x-intercepts. X-intercepts, that's an abbreviation. We have negative 4 plus 4 would work, so negative 4. Positive 3, take away 3 would work, so positive 3. And then also we have just a 0. If I plugged in 0, that would make this thing 0, so 0 works. So that's good for the x-intercepts. And then the y-intercept as well. Remember, a y-intercept comes when we just put 0 in for all the x's. And so we could do that in factored form or in a regular form.